tonight going to look at prep for your assignment. I think the mock assignment was also launched today, so we will, in our next session, we will look at the mock assignment that you guys got. So we will definitely work through that. Tonight, basically, I'm going to use a few years ago, one of those assignments to work through the presentation that I will share with you later on again. Also, if you look after the examples that we will go through, also have all the bit of information around the formulas and the steps and all those kind of things, so that we just have all of that combined into one presentation again when you have it, so that you can also use it for your prep for the assignment, for your exams, that when you're writing it, you're allowed to have those things. So then you are allowed to use it. Okay, so tonight, just going to go through a few questions on chapter 8 and 9. Then next week, I had my dates wrong. I thought you guys need to submit by this coming Monday, not realizing it is only opening next week. So we will definitely have another session during next week. Also, so next week, Thursday, we will again cover study unit 8 and 9, so that we get the most prep in for your assignment. There's also going to be a session on Sunday afternoon, so I will share that link with you guys on the chat as well. Okay, so let's look at the first question and work through the questions. So this was an interesting one that I picked up from the assignment from about 3 years ago. So in this one, basically what they are looking at is they don't give us a lot of information, but all that they say is you got sample sizes, and you need to decide which one of these will be the correct one for a sample size of 20. Okay, so let's look at the information that they give us so that we can decide what type of confidence interval we're working with. So they say the estimates below are 95% confidence interval estimates for the population mean calculated using samples. Which estimate must have been calculated using the sample size of 20? So the one that is the smallest sample. Okay, so let's look at, when we look at the confidence interval for mean, so if we use Z or T, that does not matter if we keep the confidence the same. The one that we are looking at is basically the standard error. So even if it is working with a sample, standard deviation, basically the important thing that we want to find out is what happens with this bottom one. So if n is 20, So let's say n is 20. Let's say the standard deviation was 100. So if we divide by the square root of 20, let's see what happens to your standard error. So if it was 100 divided by 4.77, we get that the standard error for a sample size of 20 would have been 22.36. So sorry, I just wanted to overdo this. So that one can see the impact. Okay, so then if it is for sample of 40, we will say, okay, still remember standard deviation stays the same. Sample of 40, 100 divided by the square root of 40 gives us 15.81. So as the sample increases, or we want to say we're going for the sample of 20. So as the sample goes smaller from 40 to 20, your standard error becomes bigger. Okay, so let me just rewrite that. As n becomes smaller, your standard error becomes bigger. Okay, so that means as standard error becomes bigger, this interval that we're going to work with will be bigger. So the one that has the biggest difference between the minimum and the maximum will then be the one that has the smallest sample. Okay, so as your sample becomes smaller, your standard error will become bigger, meaning that your confidence interval will become bigger. So the one that has the biggest difference between the upper confidence limit and the lower confidence limit will be then the one that is linked to the smaller sample size. Okay, so if we then look at the options, the one that has the biggest difference between the upper confidence and lower confidence is option C. So we actually don't know what the mean was. We don't know if it is a population standard deviation that we work with. The only information that they give us is the sample size. So then they say which one is estimated to be the link between the sample size of 20 and the confidence interval. So C will be the one with the sample of 20 because that's the biggest difference. Let's quickly check what is the other differences, just so that we can say, if we say 115.5 minus 84.5, the difference is 31. If we check 112.65 minus 87.35, the difference is 25. Okay, so biggest difference is the top one, or sorry, the smallest difference is the top one. So that means that would have been a 60. Then the middle one would have been sample 40. And let's just work out quickly what is that difference. 121.91 minus 78.09. Okay, so again, as the difference between upper and lower confidence increases, so the sample decreases. Okay, so again, sample decrease means your confidence or your standard error will increase, meaning that that difference between your upper confidence limit and your lower confidence limit will also increase. Okay, so that's why we can say it is option 3. The reason why I also just showed the other two is also because, again, you guys might get that for some of you, the option is ask for sample size of 20. Some might be needing to work out or to say what's the one in the middle, so 40. And it might be that some need to say for the bigger sample size, which one will you go with? Okay, so that is just, again, 4 different options that you might get in your assignments. Okay, I will specifically look at one of these for our next prep session as well. Okay, so this is something a bit different. Then we go into a few of the ones that is then specifically we need to work it out. So we need to work out what is the confidence interval. So first, let's look at this one to identify, are we working with a Z? Are we working with a T? So is the population standard deviation known? If a population standard deviation is known, we work with a Z. If a population standard deviation is unknown, we work with a T. So let's, Department of Basic Education, earlier findings from a survey of 150 learners. So we know what N is. Suggest an average travel time of 114 minutes. So when we put our formula together, we know that we are looking at 114 as our mean that we're working with. Assume the population standard deviation of the learners. So they tell us population standard deviation. Because it's population standard deviation, we can work with a Z. Okay, so population standard deviation means that we can work with a Z. So that means that we have the standard deviation is the population standard deviation. So that's cool. We can just put the 72. We've got 150. So let's just make 100% sure what the Z is. They tell us we're working with a 95% confidence. So 95% confidence is 1,96, but let's just quickly, I want to just show again, 95%, we're working with a 1.96. Okay, so again, nearly, you don't need to go to a Z table. You don't need to work it out. If they tell us we're working with a 95% confidence interval, we can automatically use 1,96. Okay, so let's quickly work that out. So 72 divided by 150 square root. So I just want to write this down as well, so that for you to just, if you want to follow the steps later on, where we got everything. Okay, so 114 plus minus that, so 5.8788 times 1,96. So I get 114 plus minus 11.5224. So my top one will be 114 plus that. So I get my top one is 125.52. Okay, luckily there's only one, but let's just look at the bottom. So the bottom will be 114 minus that. So the bottom one will be equal to 102.48 if you round it off to 2 decimals, which is also that one. Okay, so first we need to identify that we're working with a population standard deviation. Because population standard deviation, we can work with a Z, then this is the formula that we will use. It's the mean plus minus the Z times the standard error. Then because they tell us it's 95% confidence interval, I can automatically use the Z as 1,96. If it was a 99%, I would have gone to the table again and say, okay, well, 99% confidence, we would have worked with 2,58. And if I used 90%, we would have used 1,645. Okay, so that is just the 3 different options that we will need to use for the Z. Okay, but again, that is from that small table that is in your study guide. It's something different when we need to use the t-value. Then we will need to work that one out by looking at the t-table. So hopefully one of the next ones will focus on that as well. Okay, so let's look at this one. So because I thought this was also an interesting one. So if you look at it, consider a t-distribution. So they tell us that we're working with a t-distribution, and then they tell us, okay, we're working with degrees of freedom of 27. Okay, so that's it. Okay, so for that we will need to go to the t-table. So let me just open it. And again, I'm going to use the one that was shared as your TUT letter 101. Let's just get to that, and we will now jump a bit between the table and um, the question. So T table, let's take that out. Let's see if I can just get coloring again. Okay, working with a T table. Okay, so there's two components of it, and they said to us degrees of freedom that we're working with is 27. Okay, so I'm just gonna highlight, we'll make it bigger now as well. I'm just gonna highlight all the ones that are 27. That is just a bit easier to work with. Let's take a few of the others away. Okay, so that's the ones that we're gonna work with now. Degrees of freedom 27, and let's look at the question set. The t-value associated with a lower tail probability of 0,01 is minus 2.473. Okay, and we're looking for incorrect. Okay, so minus 2,473. So let's look 27 with the 0,01, 2,473, 2,473. And remember lower tail. So lower tail means that it's not this side, it's on the left hand side. That's lower tail. Let me quickly get the other one that I can write with. So this is lower tail, this is upper tail. Okay, so when we look at lower tail, so whatever the t is on the right hand side, which is positive, on the left hand side it will just be minus t, just like we did with the z. Exactly the same how we will interpret the t as well. So right hand side we're working with a positive t, left hand side negative t. Okay, so we've now seen that for 27 0,01 it will be negative 2,4. So the first one is correct. Okay, then they ask us in the second question, 95% of the area under this t distribution falls between minus 2,771 and positive 2,771. Okay, so let's look at 95%. So one can go to 95 and see the 17033 and say, okay, it's incorrect because we want it, okay, so 177 or 17033. Okay, but let's first look at that 95. So I would have actually had that as an option for you guys. But that is also not right. Because, again, look at what that 95 area is referring to. It's like the Z table. It is looking at that whole area. So what is our alpha if we're looking at this 95? 0,05. So what must I do? And I'm going to draw it on here. So they want us to look at the area between those 2 points that are 95. So how big is this alpha? Okay, so if that is 95, these two alphas combined will be equal to 0,05. Okay, so combined 0,05. So if we want one of them, we need to divide by 2 so that we can get actually whether alpha is 0,025. Okay, so then it becomes a different story. Then we're looking at alpha that is 0,025. So we actually, in this instance, the question is asking us to look at a two-tail. Even though it doesn't tell us that in those words, we're actually looking at a two-tail with 95% of the information in the middle. So if I want to get to that t value there, it is 95% plus 2.5, which gives me the 0,975 over alpha of 0,025. So the t value that I'm actually going to look at is 2,0518. So that is incorrect, but it's not 1,7. It is 2, let's just get that again, 2,0518. And so very important, just like we would have done with a Z table, if they ask us on a Z table, if we would between the two Z's, so please treat the Z and the T table exactly the same in this regard. So if that was the 0, they told us that this area is 95. We would have done exactly the same to say, okay, well, this area and this area is what is left is 5%. So if I wanted to just get one of these small areas, I would have also said that I need to divide the 5% by 2. And the one component will go there, and the other component of the 5% will go there. So exactly the same as we do with a Z table, we can do it with, and we can assume it is equal. So just like the Z table that, or the Z graph that is the symmetry, we can assume that with with a T table as well. So yes, you can assume it is going to be the same. And just on that, the bigger the size of your n, the closer it becomes actually a Z value. So the bigger the size of the n, you can see when we talked about Z, the 95, there was 1,96. there's for 1,645, and there's for 2,58 nearly. So even though we are working with a T table, so that is why the T and the Z is so close to one another that also when you guys do, and maybe the next one is going to be one where we look at the confidence interval. If you use a Z versus a T, your answers are going to be very similar to one another. So one doesn't always realize that when you do the confidence intervals that you might be making a mistake because the answers are so close to one another. Okay, so let's just look at the others. So we know now that one is incorrect. So let's just a t-value associated with a lower tail probability. So lower tail, again, negative of 0,025. So that's actually the one that we had now. So let's just 0,025. Lower tail will just have the negative, so minus 0,052. So that one is correct. 90% of the area under the T distribution. So now we go to 90%. So we do exactly the same, 90%. So that means that if that is 90%, we are left with 10% for these two. So 10% divided by 2 is 5% on each side. So if we have 5% on each side, what we are then working with here is actually, so if that was 90 plus a 5, we're working with 95. 95, we are sitting with a 1,7033. So 1,7033, 1,70. So we will have a 1,703 on the positive, and then on the negative, we will have a negative 1,703. And then let's just look at the last one, 80% of the area between the two. So let's do it on this side. What I now realize is that now this will only be on the video and not the presentation. I will take a screenshot of this to add to the presentation so that we just have it for you guys as well when that I can just add it to the slide. Sorry, I realize now, but it's probably going to be easier to just do a screen print and then I'll add it to the presentation. Okay, so they said to us 80%. So what's left is 20%. So again, 20 divided by 2 will give us 10%. So 10% plus the 80 gives us that we are looking at the 90%. So if we're looking at the 90%, because that's the T that we want to get, we sit with 1,314. So 1,314. So on the positive, 1,31. On the negative, negative 1,31. So let's just do a screenshot of this. Let's just add it. So that you have it. So that you can just reference it again for those ones. Okay, sorry about I totally forgot that it will not be on the presentation, but now you can look at all of it in conjunction with the T table. So nearly looking at all the possibilities. So yes, they normally don't ask us 80 percent, but they told us to use the T table, then it is okay to use it in that way. They will not ask you 80% with a Z. Um, it because let's just quickly, that will be something around 1,28 or something like that. So we will not, it's not one of the things that is standard. So they will not ask that for you in a question. So yeah, I just wanted to highlight nearly this first one, that we're looking at sample sizes with a standard error that then changes, and this question, because it's not the standard questions that we normally get, where it's normally work out the confidence interval to get the information. You need to decide if you're using a Z or a T. So that is a bit different. So that's why I thought let's just look at it and explain it a bit better for you guys as well. Okay, so next one. So let's look at again what do they tell us? And again, I know it's not easy when it's online for you guys, because I like to highlight. So because when you pick up things, so simple random sample size of 46, so we know n is going to be 46, from a normal population results in a sample mean of 300, and the sample standard deviation. Okay, sample standard deviation, we're going to work with a T. Okay, if it was population standard deviation, we would have worked with a Z, but sample standard deviation, so we work with a T. So still fine that your mean is given, but now suddenly instead of a Z, it is a T. So instead of just easy to say, well, 90 was 1,645, now it will be something different. So mean stays the same. So if it is a Z or T, that doesn't differ. That is 50 divided by the square root of 46. So again, that will not make a difference, but let's look at the degrees of freedom. So first, degrees of freedom is n minus 1. So size 46. So size 46 minus 1. So degrees of freedom is equal to 45. So let's first get to where we're going to be. 45. So these are the numbers that we're going to work with. So that is degrees of freedom of 45. Let's then see what else did they say. 90% confidence interval. So let's quickly change this a bit that we can just take some of this out. Okay, so 90% confidence interval. So that again means that that area is 90%. So that is 5%, and that is 5%. Okay, so again, if you look at that component, then we are working with an alpha of 5% and not an alpha of 10%. So again, just keep that in mind. So when we work confidence intervals, it's always a two-tail. So confidence interval, always a two-tail. So 90% in the middle, 5% on each side. So we're working with an alpha of 5%. It was, sorry, 45. I forgot. I wanted to now do what the n was, but it was not n that we're looking at. We're looking at degrees of freedom. So it is 1,6794. So 1,6794. So I'm just adding all the, so now you guys can see that if we use Z, we would have used 1,645. So very close to that. So, and you can see there's some of these that are very close. So look at those two options. Might not be correct, but just look at how close it is. Between 319, 322, also very close. So again, it might be very close when we look at the Z and the T. Okay, so let's quickly 50 divided by 46 square root. Okay, so I get that we're working with, let's just quickly do that. So if I work that out, I get 7,3721. So I hope that is right, times 1,6794. So I get that it's going to be 300 plus minus 12,38. So let's round it off to what is here. So there's all two decimals. So I will have in my final one just two decimals. So 300 plus that is 312,38. So let's look at answers. Okay, so there it is. But let's just look at the bottom one. 300 minus 12.38 is 287,62. Okay, so which is option C. Okay, so that is what we will get to, but more important, it was to identify that we're working with a T instead of a Z. So then it basically follows through, because of a T, we will need to get degrees of freedom, 45, and then you can always, when you look at confidence intervals, look at that so that you say, okay, well, the alpha is 10% because it's 1 minus the 90, and because it's confidence interval, it will always be divided by 2, because confidence interval tell me there's an upper and there's a lower side to it. Okay, so nearly we've done one where the population standard deviation was known. We've done where the population standard deviation was unknown. So nearly the next one should be proportion. And is, so proportions, let's just again write that down. So the proportion is also always a Z. So you don't need to worry about proportion. I don't always remember the formula for that, so let's just quickly P1 minus P divided by N. So P1 minus P divided by N. Okay, so let's, and obviously, sorry, that's not X, it is proportion. Okay, so let's see. Consider the following application exercise from a previous assignment. Okay, most of the school reported a decline in the number of absences following the education department learner transport program. In the sample of 150, so we've got the sample of 150 from Joe Barber District Municipality, 114 schools reported a decline. Okay, so first the proportion will be 114 divided by 150. Let's hope that is at least a nice number. Okay, 0.76. So 0.76 plus minus, and on this side we've got the 0.76, 1 minus 0.76, and that should be across that whole formula, so just not the top part. And then let's look at the Z. Construct 90% confidence interval, 90% confidence interval, 1,645, 1,645. Okay, so 0.7 times 0.24 divided by 150, square root of that. So again, I'll hope my calculator is playing with me. So 0.0349. So if I multiply those two out, I get that it must be plus minus 0.0574. Let's just see 0.76 plus minus that. So let's do the bottom one first. I get 0.7026 Okay, 0.703 if we round it off, and then the top one is 0.8174 or 817 if we round it off. So basically we're sitting with option A as your answer. And you could see they made some other mistakes. So that's a duplicate. That's a duplicate. So again, there was some other problems, obviously, with this question, but I think if one, yeah, so again, there will not be, you could have been nearly set option A because you can't have an option with a B and C that's correct or a D and E that's correct. So if something like this happens in the assignment, it will just fall away because you can't have two options that you can pick. Okay, so again, in your assignment will be the traditional questions as well of the one that's normally the population standard deviation that's known, or the population standard deviation that's unknown, and the proportion. So let me quickly. Okay, so they need to tell you that you know. So they need to tell you population standard deviation or sample standard deviation. So they need to tell you that you know what what the population standard deviation is for you to use for Z, else they will tell you to use the sample standard deviation. What they could have done also, oh, sorry, yes, in this one, because it's proportion, it's always a Z. Sorry, because it's proportion, it's always a Z. Okay, so nearly, if we go back to, so quickly just want to show this, and it's good that you ask it again. So when the standard deviation is known, it's a Z. Standard deviation is unknown, it's a T, but proportion is always a Z. Okay, so just again to make sure, because they might use in here sample, or so at least they say population proportion, but they could have used sample as well. So yeah, proportion always Z. Okay, so the first few was looking at confidence intervals. Then the last few, and that will be like that in the assignment as well. So you guys get 10 questions, roughly five will be study unit 8 on confidence interval, roughly five will be on study unit 9, that is hypothesis testing. It might be 6-4, but normally they will divide it half. Okay, so in hypothesis testing, nearly the same three things can be tested. So we can test where you need to work, where it might be that we need to look at the Z when we work with a proportion. it might be that we need to look at the Z or the T when we work with a mean. So they need to give us those information in the question if we need to make those decisions. So in this question, they said, okay, in a sample of 36, the sample mean is, and the population standard deviation is 16. Okay, so then automatically population standard deviation tells me that I'm working with a Z. Okay, so population standard deviation is known, working with a Z. Okay, so now they ask us a few things. So they tell us, okay, the test statistic is 1,285. So that we need to work out. So that we work out with what we did in study unit 7. So work out for Z. So remember, out of study unit 7, we worked out the Z for this. So let's look. Sample mean is 83. They tell us that we're looking at a population mean of 80. Standard deviation is, 16. And the n that we're going to divide by is 36. So that at least is a nice number, because the square root of 36 is 6. So for that one, we basically going to say 83 minus 80 is 3. And 16 divided by 6 is 2,667. So if we work out that, we will get the answer as 1,125. Okay, it's not the same, so that is the incorrect one. Okay, so that is the incorrect one. Okay, so that's actually quite cool. But let's quickly look at the rest of the question. So alternative bigger than 80. So an upper tail Z test is applicable because the alternative, so we will always look at what the alternative sign is. It's bigger. So the alternative tells us that we are looking at the upper tail. So if we need to look at the upper tail, so now again, back to study unit 7, Z was equal to 1,125. Upper tail, so I want to get that p-value. So 1,125. Let's go to the Z table. Z table 1,125 would give me that area. I want that small area, so let's go to a negative table, but let's just round it off, and hopefully this now does not give us problems. 1,13. So negative 1,1,13. 1,13. Okay, so what is that? 0,1292. Oof. P-value of 0,1292. Okay, why 1,303? So let me just check. Okay, so they went full out in the middle of those two. Sheesh. Okay, 1,1314 plus 1.1292 divided by 2. Okay, so they basically went, that's why I said I was worried by rounding off. So they went, those two, because it needs to be 1,125, they added the one, they added the other one, divided it to get that. So that is quite a scary one. So they used the one's value 0,1314. So let's just write it down. 1314 plus 0,1292, and because it's in the middle, they divided it by 2 to get that. Okay, that is quite a difficult one, because I would have just rounded it off. I would not have gone that route of going between the middle, and that's why I originally said that's probably going to be a problem. So they want you actually to go to, because it is slight or not, it is right bang in the middle of those two. They wanted you to work it out like that. Oh, okay. Not so great, because I would have just gone for we so taught in the other ones to round off. So yeah, that's a bit of a tricky one. Then let's just look at the other two. So at the 10% level of significance, the rule is to reject the null hypothesis if the t-test is greater than or equal to 1,285, which is correct because our z value is smaller than that. We reject the null hypothesis. And if I say at the 10% level of significance, null hypothesis is not rejected. Okay, so if it was that it falls then within it, it is again correct. So let's just draw that for you so that we just make 100% sure about this one again. So if this, and that was the t-stat that we work out, I actually needed to make this. Let's just quickly make a new one, so that we just get this right. So critical value was equal to, what was it, 1,285. The t-stat was equal to 1,125. Oh, and I should have actually showed you on this one. Okay, so if it then falls into that area, we do not reject. So you guys can actually use this as a reference. So if it falls within the left-hand side, we do not reject. So it falls within that, it is not rejected. If it falls to this side, it will be rejected. So not rejected. And if a t value was sitting somewhere here, we would have rejected the null hypothesis. Okay, so nearly if this is actually, yeah, I should have shown on, let me just quickly get to that one again. So if it falls within, it is not rejected. If it falls without it, you will reject the null hypothesis. So this is actually a nice one on the slides to reference as well. So if that is your critical value, like I say, upper critical value, and your t-stat falls within this, we don't reject. If a t-value falls with outside it, we will reject. So this is actually quite a nice example that you can reference again as you're going through your assignment as well. Again, you're allowed to use it in assignment, exam, everything. Remember, we open book, so you can use all these notes because it's open book. So again, please don't, the assignments, you can use your study guide, you can use these notes, you can use all the recordings that we've done. It is going to be applicable. Okay, so you can use it. Okay, so then let's look at again a slightly different phrased question. So suppose the calculated t-stat for a one-sided lower tail test is minus 2,74. Okay, so minus 2,74. Suppose further that the population standard deviation is known. We're working with a Z, so we can use the Z table. What is the p-value for the test? Okay, so we need to get that area. That will be the p-value. So let's look at minus 2,74 minus 2,7, 2,70, 1, 2, 3, 4, and 0,0031, 0,0031. Okay, they told us one-sided. Hey, if it was two-sided, and that again can be asked for some of the other students. So again, depending on which paper you get. So if it was two-sided, we would have needed to at this side as well, the p-value. Okay, so we would have needed to add this p-value as well, but again, to the point previously, we know on both sides it's the same size. So if it was two-tail, it would have been those two added together, which would have given us option E. So option E is actually the two-tail option, and option C is the one-tail option. Okay, so again, by giving us both, also to mislead you a bit, because depending on what table we use and if it's one-sided, two-sided, and you can see the same with option A and B, 0,0024. I just want to check where was the 0,0024. 0024. So I don't know why we would have gone to minus 2,82 to go to that space. So I just want, okay, you can't even look at that to say we're going to use a T table because we don't have enough information for T. So yeah, I don't know how they got to the other ones unless there was another question that used minus 2,82 or something like that. Okay, but very important, one tail only looks at the one side of a p-value. So even if it was one-sided upper tail, it would still have been just the one side. Okay, so it doesn't matter if it's one tail upper, one tail lower, your p-value will stay the same. Because for the upper tail, they would have just asked, so let's just cover nearly all of the options. So one tail upper would have been positive 2,74. And then it would have reference to this one of 0,0031. So again, they can phrase it a bit differently to say upper, lower tail. It doesn't only need to be always the negative side. Okay, so yeah, I thought we need to include something like this because again, it is different from the traditional questions that they have on hypothesis testing. So then we end off with a more traditional question, but on proportions. So here they ask us again something a bit different. So in a sample of 100, the sample proportion is 0,32. Consider the following hypothesis test, and we need to calculate the p-value and choose the correct answer from a list of options below. Okay, so hypothesis testing with proportion, again, Z. So we can always use the Z. So then remember this formula from chapter 7 as well. And I can't remember it, so let's quickly, I just want to see. Okay, so that was confidence intervals. So where was it? Um, now I must get to the right one. Sorry about that. Okay, so I'm going to use that for the hypothesis testing for proportion. So again, you can see it's not always that we need to remember the formulas. We can use the information at hand. And divide it by n and square root of that. So let's quickly check. The sample 0,32, population 0,4. So you can already see that at the top it's going to be negative. So 0,32 minus 0,4 is going to be minus 0,08. Let's just move all of these. That was more space. Okay, so that already tells me that I'm going to work with a negative z. Okay, so going to be a negative z, and it's smaller, so this side it's going to be my p-value. Okay, negative z, and we're working with, it needs to be smaller, so it is going to be on the left-hand side. Let's just see what we are dividing it by. So 0.4 times 0.6 is 0.24 divided by sample of 100. And the square root of that, 0,00, sorry, 0,049. So if I divide 0,08 divided by that, and just remember the negative, I get that my answer is minus 1,63. Just put this here. Away. Minus 0, minus 1,63. The Z table minus 1,63. Z table minus 1,6. 1, 2, 3. 0,0516. Let's just see 0,0516. Okay, so again, if it was not equal to, then it would have been 2-tail. So if it was not equal to, it would have been 2-tail, and then it would have been option A. So again, just be very careful. So this is the 1-tail, and it is correct because that shows us it is one directional. So happy that it is only 1-tail. So just be again careful here. They didn't need to tell us 1-tail because in this it was said that it is 1-tail. Okay, so just again, very careful with the one tail and the two tail. The two tail is only when it is not equal to, and they need to tell you. Otherwise, smaller, bigger, smaller or equal, bigger or equal, that is always one tail. Okay, so this will always be the one tail. Not equal to is when it is the two tail. Okay, so again, just be on the lookout for that, because it again can be that for some students they give a smaller, and for some students they give a not equal, and they don't need to change even the answers. The option that you choose will just be different. Okay, so that is it for tonight. Again, all the other work is with it, that there is some of these steps and things in the presentation that I will share with you guys as well. Then we will have a session on Sunday afternoon at, I think it's around 4 o'clock. I will send a link for that, and then next Thursday as well, another session, so that we can basically have, after tonight's session, 2 more sessions for you to get prep in for assignment 4, and then after your submission of assignment 4, we will focus on the last 2 study units. Okay, that is it for tonight, everyone. Thanks for joining. If